Class. Dr. Mandis here with our chemistry madness of the day. Hey, this is all about the equilibrium that we built off last time, converting Martians into Smurfs, Smurfs into Martians. We said, hey, equilibrium is about the rates. When the rates are equal, we got equilibrium. Well, today we're talking a little bit about Le Chatelier. Le Chevalier, Le Chatelier's principle, the Chateliers. And it's all about just stressing, messing with the equilibrium system under experimental conditions where we affect the rates. And since the rates are equal, if we affect one rate, then we're going to make them unequal and mess with the equilibrium. As an example of that, let's mess with the doorway. If we make like this door big door, okay? That's what we're going to do. It used to be that the rates were equal, right? We had a forward rate of Martians converting, reverse rate of Martians converting, okay? If they're equal, that's cool. The door, but would make the top door a lot bigger. Then, hey, it looks like a lot more Martians are going to get through, so that rate's going to get a lot faster. And if that rate gets faster, the amount of Smurfs should go up. The amount of Martians are going to go down. Why? Because more Martians are being converted to Smurfs than there are Smurfs to Martians. So that will affect the equilibrium and make it. This thing is called a shift. Okay, instead of being predominantly green Martians, we're going to be predominantly blue Smurfs. We shift. That is Le Chatelier's principle. That's what something. Make a rate bigger, make another rate smaller. Well, let's see. Oh, if we miss, instead of making one door bigger, let's make that make the other door, okay, a lot smaller. Make that smaller. So what's going to happen to our rates? The rates are equal. He's going, whoops, wrong way. Threw it the other way last time. Don't want to confuse you. That blue to green's happening there, green to blue there, Martians to Smurfs. Well, if we shut the Smurfs door down, then that rate's got to go down. Instead of being fast, it's going to be a little tiny little rate. So which way do you think is going to be the predominant rate? The top rate. It's faster. It hasn't gotten faster, but fast is relative. The other rate slowed down, so by default, the other rate looks faster. So this way is our predominant rate. So if we're running to the right, we're going to make more Smurfs again, going to get a lot more blue, a lot less Martians. That's all what Le Chatelier tells us. If you stress the equilibrium by messing with it, things change. I have two examples over here. First one, what if we increase the amount of H2? Whatever, we add H2. We call that a stress. Well, let's back up. We had an equilibrium. They were both equal rates. Cool. We have forward rate. Forward depends on H2 and I2. The reverse rate depends on HI. Okay. Since we're talking about adding H2, we're not talking about the reverse rate. We're only talking about the forward rate. With more H2, what's the shift? What's going to happen? If more H2, you're going to have more collisions between H2 and I2, more collisions between the hydrogen and iodine. That happens, the rate's going to go faster. So what happens is this top rate is going to get really fast. The bottom rate isn't changing, but rate speed is relative. So what it looks like is we're shifting to the right. If you learned chemistry, the arrow points to what we're making. So the end result will be, as we run to the right, sorry about that results, these guys are going to go down because we're going to use them up and we're going to make more HI. The next one, what if instead of doing that, we decrease the amount of ammonia? The reverse reaction needs ammonia. So our stress is we decrease the ammonia. How? Don't worry about that. Bleeding it off into another reaction somehow, don't worry about that. But we're just less ammonia. We have equal rates. The reverse rate, that bottom rate, needs the ammonia. So that is the one that's impacted. Okay? So when we think about the shift, is the forward rate changing? No. But is the reverse rate changing? Yes. The reverse is going to get a lot smaller. Okay? So it looks like we're running to the right. Well, what's the end result going to be? Well, if we're pointing to the way we're making things, if we're making ammonia, we're going to make more ammonia because we're making ammonia. What are we making it from? N2 and H2. So they will go down. So you have three things. What are you doing? What's that result in? It's a shift. And finally, all said and done, what happens to the relative concentrations? Alrighty. That's it for Le Chatelier. Have a good day.